Software fails in lots of different ways. It can be so low quality that no one wants to use it. It may not even work at all. We may bet on the wrong tech and run into some limitation that stops us in our tracks, or wander off into some swamp of despair where every move seems difficult, painful and slow. We can build things that aren't what anybody wants, and we can start work on what might be a good idea but be so slow at producing it that we miss the boat. Or maybe even never get to release it at all. Our wonderful product ideas may have been thought of by somebody else, and they may win the race to deliver and/or adoption. If you've been around software development for any length of time, you probably recognise all of these problems, and you've probably got your own stories about some of them. So, who is to blame when things go wrong? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I'd like to begin by thanking our sponsors, Equal Experts, Octopus, Tricentis and Transfic. They've been supporting our channel, so please do support them in turn by checking out their links in the description below. This episode touches on another of the principles that I think are foundational to the creation of good software, and that I describe in more detail in my book, Modern Software Engineering. Incrementalism, working in small steps so that we can build on progress and recover from mistakes. Working incrementally is essential to solving any complex problem and foundational to good software development. Read more in my book, there's a link to that in the description below too. In my experience, the commonest response to the question, who is to blame, depends on your job. If you're a developer, you may be thinking it's the bosses, saying things like, can we deliver faster by adding more people? Or there's a deadline looming, so we need to make sure that we prioritise feature delivery. If you're a manager of technical people, you might be thinking, are my people really good enough to do this? Or I better tell them how to do it so there are no mistakes. I recently came across a Twitter thread by Laura Taco that highlights some of the research into what people involved in software development think of each other. It's not a huge sample, but what it reported was quite interesting. They asked 165 people, developers and managers of developers, two simple questions. How do you define productivity? And then, if you were a developer, how do you think your manager defines productivity? And if you were a manager, how do you think your team defines productivity? The results were quite interesting. Developers define productivity largely in terms of activity, the mechanisms of delivery more than the outcomes. Managers define productivity quite differently. Their primary focus is significantly on the outcomes, with how those outcomes can be achieved coming very low down the scale in comparison. Okay, so this is a tiny sample, and it's quite possible that the people doing the research managed to pick an unusually enlightened group of managers and an unusually unenlightened group of developers. But if this is representative of views more generally, then it's rather interesting, because I think that the usual assumption, at least in the development community, is the other way round. Pointy-haired bosses slave-driving work to churn out rubbish, ignoring the importance of quality work, following some dumb metric for productivity, and actively ruling out sensible ways to optimise for outcomes and flow. But if this research is accurate, then it says it's the developers doing all of this to themselves. So it's all the stupid development team's fault, right? Well, no, it isn't that simple either. I don't know about you, but I've certainly seen a lot of software development teams that were being pushed by bad, or probably more likely misguided management, into making poor choices and optimizing for the wrong things. So from the developer's point of view, it's obviously the fault of the bosses, right? Well, no, still not that simple. I think that what we are looking at here is more like a systematic problem. And the way that you tackle systemic problems like this is to fix the system. I'm currently working on a new training course that describes using behaviour-driven development style executable specifications to steer the software development process. As part of this, I wanted to explore the journey from idea to working software to put the technicalities of working this way into their proper context and explain how important it was to establish a shared common working understanding of the problems that we're working on and teach people how to do that. Sorry, didn't mean that as a sales pitch, though I think the course will be very good, but I'm just setting the context here. As part of this, I came up with a way of describing all this that I rather like and that I think is more broadly relevant. If we think about software development, what is it really? Our users never really know what it is that they want, so any requirements that we come up with, or whoever comes up with them, are only our best guesses so far about what may be useful to our users. So we're always, in reality, starting out with a kind of vague wish that we assume our users have about our system. Our guesses about the nature of the wish may be wrong, or it may be spot on, but at this stage it's always vague, imprecise. We'd like to authenticate ourselves so that we can access restricted features of the system. That's the kind of thing that a user may want. They don't know how that should work necessarily. They may assume that in reality it means you're going to give them a username and a password field, but you could come up with face recognition instead. They may prefer that, even if they didn't think of it themselves. The end point of software development is to create a description of a problem that is so precise that even the ultimate pedant, a computer, can understand and execute it. A computer program. So you can think of all of software development as an exercise in translating these vague wishes into precise executable descriptions of the problem. The way to solve complex problems is to proceed in a series of small incremental steps. If the problem that we are solving is difficult, we aren't going to reach the solution in one giant leap. For difficult problems, we need to organise our thinking sensibly so that we can proceed step by step towards a solution. Why am I talking about all the philosophy of development stuff? Well, I think that this is at the root of nearly all of the failures that I see. Fundamentally, you can think of this in two ways: failing to work incrementally and doing work at the wrong point in the process. Attempting to solve problems in the wrong part of the process stifles our ability to work incrementally. So these are related, and is nearly always as a result of trying to scale up software development and making a bad job of it. Here are a few examples. Software development is often seen as a kind of production process. So the task of organising work is to collect together the raw materials and push them through the sausage factory of development. If you have this kind of mindset, you may honestly believe that you're helping development teams by doing work to reduce their decision making before the work reaches them. Organisations that work like this seem to see software development as a kind of assembly phase of a flat pack furniture process. Put peg A into slot B. If your organisation produces requirements that tell you how to solve the problem, this is what I mean. This is an extremely common failure in software development. If we work this way, then what we've attempted to do is turn the development step into a translation exercise from a precise description of the solution written in a human language, which is fundamentally imprecise, into a precise description of the solution written in a programming language. Software development is more than that. It's more creative than that. And to do it well, development teams need to understand the context of their work better than that. Narrowing their focus in this way works against that ability. So now the requirements process is the design process for the system. Mostly requirements are written by people who aren't technical specialists or were once. So this is very bad use of their skills and usually results in poor designs. They can be poor in lots of different ways. Often the design won't work at all, but even if it does, it's probably not the easiest, most effective way to achieve the goal because the people making the design choices are far away from the code. And the people writing the code are divorced from the context that informs sensible design choices. I think of requirements as the first incremental step in translating that vague wish. We want that to be a small step because that is how we really solve problems, rather than fantasizing about how they're solved by imaginary geniuses. A very good first step then is to be a bit clearer about the outcome that we're aiming for. When our VIP user authenticates themselves, they can see X, where X is a particular privileged thing in our system that only VIP users have access to. By focusing on a specific example like this, of what we'd expect to see if our user's vague wish was fulfilled, this has moved us just a little bit closer to our goal, giving us a better chance then of hitting it. It also, importantly, means that our intent is more clearly communicated to the development team. Another example from this kind of anti-pattern of software development production line is separating testing from development. My guess is that still, even today, the commonest pattern for organising work in larger development teams is to attempt to offload responsibility for testing to somebody else. A QA team acting as gatekeepers to production, perhaps. This is another very common cause of failure. Teams that work this way have a built-in delay in their development process. They have inevitably introduced a communication overhead, and this very often devolves into a horribly bureaucratic process to manage it. I can't work on that bug because I can't reproduce it. Or, that's not a bug, that's a feature. Or, I can't fix that now, I'm busy. Maybe we need better tools to track and triage all these bugs. Or maybe worst of all, that's what I was told to build. I knew it was a bad idea. I see all of these being down to, once again, work and responsibility being in the wrong place. Developers create code that has bugs in it. Developers are the only people that can fix bugs when they're found. Wouldn't it make everyone's life easier if we could just spot the bugs sooner and tell the developers directly? Ideally, as close to the point where the developers introduce the bugs as possible. We certainly don't want to slow people down, so we want developers to focus on development. But we also want developers to get the clearest picture possible that their work is on the right track, both technically and from the user's perspective. So if developers structure their work to maintain this clear view and they want to work efficiently, they must own the responsibility for confirming that their changes work, testing it. This is what test-driven development, behavior-driven development, continuous integration and continuous delivery are all about, really. Working this way, prioritizing for this fast feedback on mistakes, has some other really interesting knock-on effects. At the technical level, applying the techniques that give us this fast feedback, specifically fast detection of failure, encourages us to work in small steps, so incrementalism is enhanced. This means that we learn more quickly. One of the things that we learn is whether our design choices are working out or not. This gives us a profoundly valuable tool that allows us to grow our design and architecture incrementally too. So we end up with better insight into our code, better quality, an enhanced ability to work incrementally in small steps, and better architected systems, all by putting the decision making in the right place into the development process. My argument is that if we want to do a better job of software development, we must think differently. Production lines are a terrible model for software development. Software development is a creative process and is fundamentally about learning and managing complexity. You aren't learning much if your product owner is telling you the solution. You aren't learning much if your architecture team makes all the significant design decisions. You aren't learning much if you're so focused on trying to specify solutions to development teams that you aren't focused on what your users really want and what they made of the last stuff that you gave to them. You aren't learning much if your QA team is reporting bugs as hard to understand bug reports. There's one more huge advantage to putting responsibilities in the right place. It demands better, more effective communications. I think that my model of software development as a translation from vague wish to useful code in a series of small incremental steps helps us understand this a little bit. We capture our vague wishes as user stories, real stories about people using the system. From that, the next step is that we come up with simple examples that are a bit more precise. If these examples existed, they demonstrate that the need expressed in the user story was met. We translate those examples into executable specifications, specifications that we can run and confirm that our example really works and exists. This is another very small step using the techniques of BDD and acceptance testing. We use these specifications to guide development, running them as we work, regularly as our software incrementally evolves tiny step by tiny step. We use other forms of tests to validate that our code works at the technical level too, as well as that of our high-level examples. Between them, these tests, these side effects of the way that we do specification and design, will quickly point out the vast majority of our mistakes. When we make a mistake, maybe that highlights that our design choices in the past were wrong, so we can change the design. Again, this relies on decision making being in the right place, in this case in the development team once again. This is how I prefer to organise things. To make this approach work, effective communication is fundamental. But so is a form of delegated responsibility for decision making, so that the right people can make better informed decisions at the right time. We need to have a shared view of our goals. Oh, hang on, don't our user stories define those? We need to have a clear understanding of what it means to say that our code is done and ready for release. I think that passing executable specifications do that for us, so that problem's solved too. We need confidence to make incremental changes. Our tests give us all of that too. There's a significant cost to getting all of this stuff wrong. I think that cost is at the heart of nearly all of the failures in our ability to reliably and sustainably deliver better software to our users. My take here is strongly agrees with the data. One of the main predictors of success in software is the ability of teams to make decisions on design, architecture, scope, and generally in organising their work themselves. Software development is about developing software. So although it sounds like a lot to ask, this is the job of software development teams. And overly simplistic attempts to reduce their workload often serves to increase it instead. Thank you all for watching.